Hello and welcome to the next stop in our tour where we're looking at different feedback systems. So today we are going to focus on some things we can do with post-processing effects. And in particular, what we're going to be doing is using post-processing effects for creating a visual indicator that damage has happened. So there's going to be a couple of systems for this. We're going to need a post-processing effect. So we'll be setting up a basic one there that's our own custom one. We're also going to be needing some logic there behind that to control the effect. And what I want to be able to have is that effect where we see sort of damage lines come in from the screen and then fade out a bit. So we want to have that as the setup that we're going for with this. So let's dive on in and see what we've got setup wise. So it's similar to the previous levels. We've got our pylons, but if we take a look at our pylons, they now have these large triggers around them. And what happens is the pylons are keeping track of these damage receiver objects. So damage receiver object, when it enters, gets added to a list. When it leaves, gets removed from it. And I'm using try get components so that if that fails, it's not doing a allocation there for it. So what happens is then when we would play the impact, it looks for any damageable objects. Because that might have been destroyed without triggering an exit, it handles safely clearing null. Then it gets the 2D distance to the target, and then it works out the maximum range and gives us a damage level based upon that. So the idea is the closer we get to the pylon, the larger the amount of damage that we'll experience is. And then the damage receiver at the moment just displays the amount. And we also then have, if we take a look at our post-processing volume, we've already got this damage overlay. And I've set this up as, at the moment, to begin with, it's just a pretty much the bare minimum version of a post-processing effect. So our C# side and then our shader side, which the shader side is just doing a pass-through. So very, very minimal, but it gives us a starting point there with this. So we'll also just take a look and see, and this will appear in the console. We'll notice no damage, but once I stand nice and close, then it's experiencing a bit of damage. If I move further away, then damage happens again, but a lower amount. So what we want to do is we want our shader to be able to control, to indicate the damage. And I've already also set up a texture, which we take a look at this texture. It's some distorted lines there. Now, we're not ever going to be displaying the entirety of the texture, and really, we're actually interested in the intensity of a pixel there. So from black to fully white, that's the only part we're actually after for it. So those white sections will come in as these red lines sort of snaking in from the edge of the screen is what we're going for. So for building up the shader, what I want to do is, before I even have the damage linking up, things like that, I want to actually get the shader up and running. So what I know that I'm going to need is, because this largely is a vignette. If we take a look at the behavior of what a vignette does, so if I add in vignette and we adjust the intensity, then that effect is largely what we're after, is similar to the vignette. The difference is that this is going to be textured. So that gives us a bit of a sense of the parameters that we want. So when we're setting up our shaders, there's a couple of key sort of things that we need to be setting up here. So we want to get our parameters set up. So firstly, we're going to have a couple of key ones. One big one is we're going to have an intensity, which that intensity, I'm going to start that at 0. because I don't need it to be, we don't want it to be starting with the appearance of, well, you are now fully damaged. So that's going to control the overall intensity of the effect. We're also going to have a color parameter, because this is going to indicate what that tinting is, what color we want there is for it. So damage color, and that's going to be a new color parameter where we'll default the value to red. We also need our texture, so we have a texture parameter. So we'll call this overlay texture. That's a new texture parameter, and we default that to null. So those are our core ones controlling what the general effect is going to look like in terms of color, intensity, texture. Now we need the things that are going to control that vignetting effect in terms of how rounded is the vignette, how smooth is the vignette, because we can make it a really sharp cut, or we can make it that it fades over a distance. We can make it that it is very squared off or very rounded. We've got a lot of controls there. So the ones that I'm going to need is I'm going to need a float parameter. And so this is going to be the roundness. Roundness, so new float parameter. And we're going to start it being fully round. So we start it, so it's got a value of 1. We also want our smoothness. So float parameter, smoothness. And that, we don't want it to be, sort of fully smooth to begin with. We want a little bit of the level there. So I'm going to start that at maybe 0.5. So halfway between, and then we can adjust that afterwards. So, okay, that's cool. We've got our roundness, we've got our smoothness, we've got our intensity there. We also, so the way vignetting works is it's actually fully changing the color. We kind of want this to more overlay on top. So this is something where I would actually have a float parameter for the opacity. So new float parameter value, and I'm going to default this to, let's say 0.5 as well. So, okay, that's good. Gives us our parameters. Then in terms of how we pass these through, it's not too complex, the process for passing them through, and we'll take a look and see how that actually works. So what we do is we go property sheet and properties, set float. Now I'm going to follow sort of the general naming convention where it's going to be these with an underscore. So set float, we have that. So that's going to be settings, and we can then retrieve intensity, which is good. So we're going to have similar for settings, smoothness, roundness, and opacity. So we'll just get all of these through. Again, following that naming convention. So once we've got these, we'll then be able to set up the shader side of it. So we'll need to make it that the shader has access to these, and then we'll need to start actually making use of them. So we can pass through the color as well. So set color. I'll grab that in a moment. We can see we've got it called damage color, so we pass that through. And then the final one we pass through is our overlay texture. So property sheet, properties, set texture, overlay texture, settings, dot overlay texture. So there we go, we've got our key parameters that we're going to need. So then for setting these to be accessible in the shader, what I'm going to do is I'm just pasting these in so it makes it easy for me to remember. So we have another texture sampler. That links to our overlay texture. We then have our color. So our color there, we can probably bring that through as a half. So damage, color, so that's those two. Then we have our bank of floats. So these will just all be halves. Clean out that. And then we've got our parameters good to go. So now we've got our shader configured, so it's got the parameters there. Our post-processing settings is configured to be bringing those through. So we can actually start using these parameters now. And so everything we do goes into the fragment function here. We're already retrieving the pixel color, and at the moment we just pass through that pixel color. So what we want to do first is setting aside the damage color, anything like of that. The first thing we want to actually do is make it so that we've got this reliably doing a bit of a vignetting effect. So to do that, we need to get the distance of the current pixel from the center, so in the screen coordinates. So we can grab that, so half to vec from center. That we can take our texture coordinates, it's xy, and we subtract the center of the screen. And then because we don't really care whether we're up, down, left, right, we actually just want that distance, I can just do absolute. And then typically I want to then scale that by the intensity. So what the intensity does is it effectively increases the distance. It scales up the distance. So this, we're getting the scaled vector from the center. And what we'll actually end up finding is this intensity value, we're going to need to make it higher. But we'll take a look and we'll see what we do with that. Now what we want to do is factor in the roundness. So we do this using a power function and we push the values out effectively. So the power functions work really well for achieving that roundness. So what we can do is we can say, well, vector from center is equal to pow. Now we want to make sure that vector from center isn't going over 1. So we can do a saturate that will constrain it to that 0 to 1 range. And we provide our vector from the center. And then we use our roundness. So we're applying the roundness. So now we've got a distance from the center that we've applied our roundness to. Now we want to work out the actual final distance there. And it's actually kind of the squared distance is what we're calculating. And it's not really, I guess, a true distance. It's kind of a intensity. It's a distance factor would be a better term for it. So actually I'll use a half dist factor. So what we can do with this is we can saturate. Now, if we do a dot vec from center with vec from center, so dot product of those two, that's going to give us the square of the distance. Now, we want it that, because at the moment, the center is going to be 0. We actually kind of want to flip that around. So what we can do is we can say 1 minus that. So that gives us our distance factor. So we calculate the distance factor. Then we want to apply our smoothness, which the way we do that is again using our power function. So our dist factor is pow, dist factor, smoothness. So we're applying our smoothness. So now we've got a value that we can use for then determining how intense we should be applying the vignette. So what we can do is we can work out what would our tinted pixel color look like? So half-3 tinted pixel color. That is going to be, we do a lerp from our current pixel color to, in this case, 3, 0, 0, 0. So to fully black we'll use for now. We're not going to use our damage color. Actually, no, we can use our damage color. Why not? So our damage color, and we do this by 1 minus our distance factor. Because of how we're doing the lerp there. We could also lerp that the other way around. So that actually, because, and this is the thing with the lerps, you'll often see this where, because I'm going from the pixel color to the damage color, well, distance factor when it's 0, it should be fully damage color. Whereas I want it when this evaluates to 0, it'll be pixel color. So I find it tends to read a little bit better if I'm lerping from what it currently is to what I'm wanting to change it to. That tends to work a little bit better for me, or not necessarily work better, it tends to make more sense for me. So we've got our tinted pixel color, then our final pixel color, because we might as well apply the opacity as well. So our final pixel color, we can do a lerp from pixel color to the tinted one, and we have our opacity. So we can take our opacity and apply that. So we are calculating the tinted pixel color, and then we apply opacity. So let's test this out. This should be enough that we can actually see our vignette happening. And that's where we want to check that that is actually happening. So our overlay texture, we're going to link that up. So we do get some errors with the value cannot be null, which if we look is coming from where we're setting the texture. So that's just something where what we want to do is make sure that with this, it's actually checking beforehand that it's got a texture before trying to set it. So we're going to make sure that that is not equal to null, and then it will attempt to actually set it. That way then it's just not going to be outputting all those errors. And we can link that back up to the texture, which would be good. And then with our shader, we just want to make sure with this, avoid, it's a really hard habit I find to get out of, is when we're working on stuff in C#, you go to a shader and you automatically end up putting in an F, which as we can see, makes it grumpy. So hopefully that's all of the F's found. Looks like it is. So we can see we ramp up the intensity. It is fading in, but it is very, very faint. And that's because what we'll find is with these parameters, we actually need to give them a much larger range. And we can sort of experiment with that. And if I adjust these, so I'm going to give all of these a range as well. But what I'm going to do is make it that these can go quite a lot higher, so we can kind of get a sense of what ranges we want for these. So let's take a look at with the intensity first. So intensity, we probably need to support a value, I would say up to maybe around 5. So I think intensity, going for a 0 to 5 value is going to be pretty solid. So what I would do there is this can go back 0 to 1, because that's still a nice value, easy thing for everything to work with. That's kind of the expectation. But we do a mathf lerp from 0 to 5 based upon that intensity. So now we've still got our 0 to 1 value, but it's now corresponding to a larger range. And that works pretty nicely. I'm happy with that. So let's take a look then also at something like our roundness. So roundness values below 0 kind of look a bit weird, doesn't really make sense. Above that though, looks like it does actually make sense, especially for some effects we might want. So really we want kind of a range of, I would say probably 1 to, I feel like 5, maybe even 6 or 7, but I'm going to go for 5, looks about right. So we want a 1 to be, so 0 to 1 range is going to correspond to 1 to 5. We kind of need to flip it, because when the user selects 1, so fully round, that should correspond to 1. But when they select 0, that should correspond to 5. So we need to do a lerp in that kind of flipped direction. So our roundness is going to be that. And then what we will do is we're going to do a lerp from 5 to 1 based upon that roundness value. So now it's set to 0, set to 1. Well, actually that can go over, so we will adjust that so it's back to a 0 to 1 range, and our opacity obviously can just stay at a 0 to 1 range. So this will work a little bit nicer. Go to 1, 0, so it's good. That's behaving the way that I kind of want, which is excellent. Our opacity is also behaving the way that I want. So that's looking good. Then our smoothness, well, let's take a look and see the range for that. So that's at 0.5. That's at like 5. And if I drop it to 0, it very rapidly becomes just a really hard edge. And actually at that point, kind of breaks the tinting. So I would actually go for probably 0.1. So there's still a little bit there. So 0.1 to 5 is what we want to do with the smoothness. So again, a lerp from 0.1 to 5 based upon that. So it'll give us a nicer range for the controls, which is what we're after. So that looks pretty good. We can go fully smooth, we can step it back. So I'm pretty happy with that. That looks good. So we go for 0.5, maybe 0.3. Yeah, so that's at an intensity of 0.5, and so that's scaling through quite nicely. So excellent. So we've got it applying a vignette with a bit of an opacity there on it, which is working nicely. We've got that tinting there. The final bit that we really need to add for just completing the visuals there for the effect is going to be the texture. So we've already got our texture available in the shader, we're just not sampling it. So with this, I'm going to go for a, we'll call this damage overlay intensity, and maybe I'll just call it overlay intensity. So we again are sampling from the texture, but we only need, because that texture we're treating it as it has to be grayscale, we don't need to sample anything else. We're fortunate that the UV coordinates, because we've already got ones that cover the screen, those will work nicely for it. So we've got our overlay intensity, and there's not too much we need to do to actually apply this. It's pretty straightforward for being able to apply it. Our opacity, we multiply that by our overlay intensity. And if we take a look, now we have these coming in. So as we get more damaged, we get more of this visual effect being brought in, and it just fades in really nicely. So that is looking pretty cool. We've got our visual effect going. Now we can actually link this up to some gameplay logic. We can link this up so that it's causing the visual effects that we're after. So, okay, this is good. So this is where our damage receiver comes in. So we've got our damage coming in, and what we want to do is we want to firstly convert that to a percentage value. So to do that, we want to be keeping track of our max health. That way I can turn this, so damage percent. I'm going to clamp it between 0 and 1 just in case there's been a huge chunk of damage done. But amount divided by max health. So now we've got something that's expressing the amount of damage in a percentage, and specifically something that's going to be between 0 and 1, which is great. So we're going to have these values come in, and that's going to spike up the intensity, and then that intensity needs to decay. So we kind of need a couple of values here. So we're going to need, we'll set up our control parameters in a moment, but we want to have our target intensity is 0. What we do is then target intensity is target intensity plus damage percent. And again, we clamp that between 0 and 1. So, okay, we've got our intensity is going to build up. We also then need our intensity to decay. So we want to also then have serialize field float decay rate, which we don't want this to decay too quickly. We want it to decay a little bit over time. So I might go for 0.1, maybe 0.2. That'd take 5 seconds to fully decay. So what we would say is, well, if target intensity is greater than 0, then target intensity, so mathf clamp 0, 1, target intensity minus decay rate by time.delta time. So decay the target intensity. Then we would also have a rate at which it slews towards that intensity. So serialize field. Now we might also have that we have 2 rates there. If our target intensity is below our current one, then we might want to slew slower than if it's above it, for example. So I'm going to actually have an attack rate, which I'm going to make pretty rapid, and a release rate, which I'm going to make it essentially that it should follow largely the decay rate. We'll be able to adjust these a bunch as well. So that looks pretty good. So that means then we have current intensity is 0. So we need to slew towards that. So we would again just be checking if current intensity is not equal to target, then we can do the slewing. So in terms of which one we use, so float rate, if current intensity is less than, actually I'll write it this other way, target is greater than current, then we use attack, otherwise we use release. And then what we would say is our current intensity can use a mathf move towards. So we're moving from current intensity to target. And our max delta is rate by time.delta time. Intensity needs updating. So that's good. We've got that. Now we just need to link this to our post-processing effect. So if I bring in the namespace here, we're going to want that. So using that namespace, because we're going to retrieve the particular settings and update stuff based on that. So we'll grab this as well, because we want to be able to track down and locate our volume so that we can update that. So to be able to do this, we need to know which post-processing volume we are talking to. So we're working in the built-in pipeline, which means we used post-process volume. So linked PPV, that looks good. And then what we'll be able to do is we actually can cache here damage, and what we're storing is this. So damage overlay settings, and then we can retrieve that by, we can go, okay, well, linked volume, we grab that, we can grab the profile, and we can go try get settings, and we can say that we want to retrieve the damage overlay, and then out overlay settings. So that just gives us the settings, which means we can just easily update that as we're running, because updating the settings then down here becomes overlay settings, intensity value is equal to current intensity. So we are ready to test this out. And we'll actually bring our game view all the way up here. So we can see our intensity over here. Now we forgot the easiest thing to always forget is linking up the data that we need. So easy to always miss. So then with that, so we don't have any overlay at the moment because we know we're in range for doing damage. So let's get close enough that we should start to receive a little bit. And we'll step way closer. So we're not really seeing a huge amount fading in yet. So what we can do is we want a little bit of a way to debug this and to see sort of what's happening with that intensity. So what I'm just going to do is make both of these public. So just make it easy for us being able to see what's happening with those. It might be that we have settings a little bit too aggressive with stuff like of our decay rate, which is fine. We can adjust that. So we head in here. We do see it does get there and start to build up, but it does decay pretty rapidly. So that's where I'm going to drop that decay rate quite substantially. So that's a little bit better. I think that's something where we're probably getting a bit of competition between the attack and decay rates, where it's not managing to sort of have it build up quickly enough. Stand much closer, then we start to see bits coming in for it. And what we can do is, if we get this centered nicely there, we can experiment with, okay, let's up the attack rate to pretty high value. So it should fade in really quickly. So impacts, we see that. And the other thing is the actual damage amount is not going to be causing a huge level of intensity there, because it's going to be doing about maybe 10 to 15 points of damage. So if we want a bit more intense, if we lowered our health, then it's much more dramatic. But we'll bring that back to 100. And we can see it's going to fade out, and that is pretty slow on the fade out, so we can probably, that release rate can probably go up higher as well. And so we can see it fades in, disappears over time, which is good. So what would be great with the damage effect is if, as we progressively take more and more damage, that intensity still stays built up to a certain level. So what I could do is I could actually be keeping track of my current health. So I could actually say current health, which we'll set that up here. So current health is equal to our max. Then down here, when we take damage, current health is going to be the mathf clamp. And we want to clamp current health minus amount between 0 and max health. So that's good. We've now got something that's updating. And what we want to do is our intensity here, that there is essentially a base level that it can't go below based upon our health value. So I'm going to set up an animation curve. So animation curve, and this is going to go from our health to the base intensity there. So intensity due to health. And what I want to then do is here, I will evaluate, and I'm going to use my current health divided by max health. So we would say target intensity is the mathf max of intensity due to health and what it was before. So it can go above this, but it can't go below it. It's essentially ensuring that there is a floor there for it. So that looks good. Once we fix up a typo. So then this curve, when the current health, what this curve needs to look like is it should start very high because that's at very low health, and then it should go down. So rather than being a curve that looks like this, it should actually be the opposite of that. So have 1, and then this one should be 0. And then we can flatten that out a little bit so that it's not going below, because that would not make a lot of sense. And that looks pretty good. If we take a look at how this is working, we'll move close so we take some damage. We'll take a larger chunk of damage. So what we notice is once we've taken a little bit of damage, and at this stage we've maybe taken 20%, it doesn't really fade away. And we really want it to. We don't want it to be that intense. So what we want to do is our curve here. Two main things I want to change is that maximum intensity. I actually want it to only be 0.5 so that it's got room to bounce above that so we can still get an indication of damage. I'm also going to make that curve a little bit shallower, because what will happen now is this will mean that even when we're on fairly low health, we'll still get a nice clear damage indicator. So we're here, we're fairly close to this. So we get that spike up, but it's not staying a huge amount. And again, because at this stage, we've only probably taken about 10-15% of damage. Now this one kicks it a little bit higher, and we see a little bit of the effect is actually remaining. And again, it bounces up and then recovers. But it's still staying fairly high because of how strong the amount of damage is. So we've taken quite a lot of damage at this stage, and so the effect doesn't have much of a room to go. So that's something where we could also adjust the actual intensity we send through. So we could actually have a max effect intensity, which we might set to 0.75, maybe even 0.5. And then when we send the intensity through, we can just do a loop from 0 to max effect intensity based upon that current one. So it keeps it still being processed internally exactly as it was before, but it just means we're capping how strong that effect can actually be. Which that again will avoid sort of it being too over the top on the screen. So that's going to, we'll get a bit closer. So we're not really getting a lot of strength there to the effect. So that might mean we bump that up to like 0.75. And now that effect fades in a little bit. And a bit stronger again. And again, we get that pulse in and that fade back out, which is what we are after. So that's looking good. Can run again. So that's a pretty high level of damage at this stage, but still has enough headroom that we do get that pulsing there on it, which is good. Because it's never going to hit the point where it entirely saturates it. So it means we're still giving that feedback that there's been a further impact there. So even if we're on really low health, that will still get properly communicated there to the player, which is awesome. So just recapping the stuff that we've got set up. We have our post-processing effect. That post-processing effect is functioning in many ways similar to a vignette. It's tinting, and we set up our key parameters here, pass those through. Shader is pretty simple. There's not a lot of stuff to what it's doing. It works out the distance from the center of the screen. It then uses exponential functions to round that off a bit, to smooth that so we can have gradual changes there. And then it works out what the tinted pixel would look like and then blends to that using a texture. So how we change that texture would really control what those sort of visuals look like as they fade in. Then in terms of receiving that damage, what we were doing is when it comes in, we convert it to a percentage. So it always works better if we keep things in our 0 to 1 ranges. Once we've got that, we then bump up the intensity we're aiming for. And then with that intensity we're aiming for, we apply a bit of decay first. We also clamp that so it can't go below a threshold based upon our current health. And then what we do is we slew towards that intensity, and we have different controls there for whether we are heading to a higher value or towards a lower value, just to allow us a little bit more control over that. And then we set an overall effect intensity so that we can just scale those effects back a little bit if we need. So this gives us a thing that we could be placing on our player. We could link health up to retrieving health from the necessary areas and then be applying those visual effects there based upon what's happening. And that then ties in with our audio feedback that we've got, with our haptic feedback, with our screen shake, all to really create that sensation there of what's actually happening. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project is up on GitHub and you can use that code for any of your own projects, and the link to that's in the description below. If you have found the video helpful, please do chuck in a like and subscribe. It really does help out and it's really appreciated. If you've got questions, chuck in a comment below. Or if you want to submit a question for the next Q&A video, I've put a link to that in the description as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link to that you'll find in the description below as well. But until next time, bye.